In this video, we'll use the slope-intercept form of a linear equation to create a graph of this linear equation. First, recall that the slope-intercept form is given by y equals mx plus b. And in this y equals mx plus b, x and y are variables, and m is denoting the slope, and b tells us where the y-intercept occurs. So for this first part, we're told to identify the slope and y-intercept of the linear equation y equals negative 1/2 x plus 4. And then in the second part, we're asked to use that slope and y-intercept to graph the equation. So for this first one, we have y equals negative 1/2 x plus 4. And m is the coefficient on x, which in this case is negative 1/2. So we know that our slope for this line is negative 1/2. Now when we go to graph this, the slope is rise over run, and so that fraction negative 1/2 we can use to determine that as we move from one point on the graph to another, we go down 1 unit, and then we go right 2 units. So that's how we'll visually interpret that rate of change of negative 1/2. Another option to note real quick, this fraction negative 1/2, we can think of it as negative 1 divided by 2 or 1 divided by negative 2, and that will be helpful as we read the graph in that we could go up 1 unit, but then we would have to go left 2 units, and I'll show this as we sketch that graph, how both of these work out. Okay, so we have the slope, and we've written some information about how we'll use that when we sketch the graph. Let's look at the y-intercept now. So in this y equals mx plus b, m is the slope, and b tells us that the y-intercept is going to correspond to the point 0, b. So for our y-intercept here, we know that we will need to plot the point 0, 4. Okay, so now we have our slope and our y-intercept. We'll start by plotting the y-intercept and then using the slope to determine more points on this graph. When we've finished, we'll draw a straight line going through these points. So the first thing I want to do is scale and label these axes. I have a 10 by 10 grid here, and so I'm going to label the axes with x and y, and then I'll make each of these tick marks worth 1 unit. So I'll mark off a 5 and a 10 on each axis, and then I'll also mark off a negative 5 and a negative 10. And the first thing I'm going to do is plot that point 0, 4. Now that I have the point, I'm going to use my slope to determine other points. So I will go down 1 unit, right 2 units. And I can now see that I can put another point there. Continuing on, I'll go down 1 unit again, right 2 more units, down 1 unit again, right 2 more units, down 1 unit again, right 2 more units, and I can see that there are more points that I can put on this line. Okay, now I mentioned that with the slope we could go up 1 unit, left 2 units. And so if I go back to this point 0, 4, and I'll go up 1 unit and left 2 units, I'll now be at negative 2, 5, and I could go up 1 unit, left 2 units again, and I'd be at negative 4, 6. And so I have further points on the line over to the left here. And being able to use that slope both ways can be helpful just depending on what parts of the graph we're trying to reach. So at this point, I have plenty of points plotted for this line. I'm going to connect them with a straight line. The last thing I'll do is add arrows to this graph showing that it continues on. And that line represents all solutions to the equation y equals negative 1/2 x plus 4.